Welcome back to Everything Swift. Firstly, sorry for not posting videos the other 2 days. Recently, Apple had the annual WWDC event, so I'm just spending most of my time trying to soak in all the information, binge watching the WWDC videos. But yeah, I'm back. Today we'll be tackling Leetcode question 98, titled Validate Binary Search Tree. So essentially, we are given a root, and we are supposed to determine whether this entire tree node is actually a valid uh, BST, which is binary search tree. So what is a valid BST? Essentially, the left subtree node has to be less than the current node's key, the root key, and the right one has to be greater than the root's key, right? And every subsequent child of the subtrees must also be a binary search tree. So as we can see in this example here, one which is the left subtree, oops, one which is the left subtree is smaller than the root, which is 2, right? So it is the first check is valid, and the second one is the right subtree is greater than node, right? 3 is greater than 2, right? In this case, there's no further child, but if like there is childs below like 3 towards the left and right, this same current rule applies as well, right? So at every point at each node and each child, these two checks has to be valid, right? The left one has to be smaller than the current node, and the right one has to be greater than the current node, right? So to solve this problem, what we're going to try and do is basically we have to traverse the entire tree and check whether at each point in time whether they violate these terms, right? At any point in time, if it violates these two condition, uh, then we know it's no longer a valid tree, right? So let's do this. I'm just going to do a quick boundary check here. If it's nil, then that's it. There's nothing further to check. Um, so because we're going to traverse, I'm going to use a sort of like a recursion function here. So I'm just going to call it isValid, and then root is 3 nodes. I'm going to pass in 2 variables here, which is min and max. I'm going to make this optional, and I'm just going to return this function here. So it has to return a boolean just to match the expected return function. Is valid root, root, and nil, right? And at any point in time, if it's nil, we'll return true. Okay, so we have to check for these two conditions, right? So let's try and do that. If because this is optional, I'm just going to unwrap it here. If min val equals to min, and we already do this safety check here. If root equals to nil, it will just return, so we can just force unwrap it here. If root.val is less than equals to min val, then we know it's wrong, right? It is no longer a valid thing because it has to be less than the current node's key, and the minimum value at this stage, if any value is below the minimum, means we violate the boundary, right? So that's a false. And the same thing we can do with max val, which is if the current root is bigger than the maximum boundary, then it is not good. Oh, sorry, this should be false, typo, right? So these two, if and else if, is basically doing this two conditional check here, right? So in the event if it is valid, what do, right? We want to continue the traversal. We'll keep continuing until it breaks out and there's no further nodes, and then we'll return true, right? So at any point in time, if it doesn't fall into the if and else if check here, we should continue traversing the tree, right? And this is where the recursion comes in. We'll do the isValid root left min root val, and we have to do it for the right side as well. Root dot right root dot val is the min here, and this would be the max, right? So essentially, like if you use this example here, if we are going to check for this left node, which is root dot left, so in this case this is 1, right? So what is the maximum value here? It should be the root, right? Because anything towards the left, for it to be valid or invalid, it should be less than this particular node, which is why we pass root dot val. In this case, it will be 2, and root dot left is 1, right? So the maximum value at this level of the check is 2, right? Because this is the current node here. And for the right side, when we go to the right, we are checking for anything that can be more than 2 to be valid, right? So that's why the minimum of it is 2, which is why we pass root dot val here as the minimum parameter, and the root dot right is basically the next root that we're going to validate. So this recursion just keeps happening until we break out, and then we'll return. So yeah, so at every stage we're just checking, is it violating any of these two conditions here, if and else if. If it's not, it will keep recursing, and then we'll break out at some point when there's a either if it's false or if it's true, right? So we just, yeah, keep reiterating. uh, yeah, let's just try and run this. There we go. Let's try and submit this, and there we have it. That's the answer here. Yeah, we use recursion to solve this question. At every stage, we just trying to check the values. If it violates any of the condition, we return false. If not, keep recursing all the way throughout the entire BST. Yeah, so as always, I'm trying to grow this channel. If you guys find this helpful, feel free to subscribe to this channel. But until then, thank you so much. Have a good day.